When you talk about the first principle, now it is actually, if I consider a simple curve, okay, the straightforward formula is given in your data booklet. And the formula that you have is the derivative of any curve f dash x or dy by dx is given by limit h tending to 0 f of x plus h minus f of x over h. Now, what does this mean? This might you if you're not clear with these notations, let's just hang on for a second. Now, what happened is that consider the in lame language, the derivative is actually slope. Derivative represents the slope. Now, when you define, like, for example, slope is change in y, which is y2 minus y1 over x2 minus x1. Now, when you look at change in y is actually represented by dy and change in x is represented by dx. So change in y over change in x under certain condition, obviously, where you have this particular formula to take care of. But this in lame language, it is nothing but the slope. Now, slope in general will be a like wrong word. So let us understand what does it actually represent when you talk more specific terms about, like, the derivative as for a particular curve. Now, let's say if there is a function f of x here, y equals to f of x is the function, and this is, let's say I take x coordinate here is here's is the x coordinate. My corresponding y value for that function is f of x. Now what I do is I take further one more point on the curve, which is whose x coordinate is, let's say, x plus h. Taking x plus h is for a reason, like x plus h is this x coordinate, so y coordinate will be f of x plus h. Now when you talk about f of x plus h, now let us say these are the two y values, and now if I find out the slope of this chord, the slope of this chord that you'll see for the curve will be, slope will be y2 minus y1 over x2 minus x1. So when I say y2 minus y1, it's going to be f of x plus h minus f of x over x2 minus x1. Now x2 value is x plus h minus x. So this and this get cancelled, and as a result of that, we get is f of x plus h minus f of x over h. Now this is the raw formula for us that calculates the slope of this particular chord. This is also what you can say is the average rate of change, like average rate of change in the average change in the, what you can say is the x value, and average change in y value over with respect to the change in x. So when you logically look at the entire formula, this is still not the one which I want. Now, what is so specific about this formula is this particular term. Now, when you look at the particular point here, guys, let's say this is point A and this is point B. I mean, this A and B here. These points seem to be far point. Now, our objective actually is to calculate not the average rate of change. Like average rate of change is basically, I know x value and I know y value at different intervals where x and y, x, like for example, let's say at certain time x was 1,3 and then you have x is like 4,8. We'll say average rate of change of y with respect to x is 8 minus 3 over 4 minus 1. But this is going to be straightforward sort of slope application, like the formula, like how you did y2 minus y1 or x2 minus x1. Now, at a point, like when I want to find out the slope, which is also referred as instantaneous rate of change. Now, instantaneous rate of change is also like slope at any fixed point. One point I want slope. Let's say there's the curve and I want to find out the slope, like, slope at this particular point. Now, when you have instantaneous change of slope, then at that point, what matters the most is you consider that these two points are not very far. And what I will assume is that if this h value is very close to 0, if h value is very close to 0, what it means is these points actually A and B are very close on the curve. It's like probably like, you can't differentiate them. And now the same chord that seems to be like chord, I mean, same line AB that seems to be chord. Now what happened is that this becomes like a tangent. So that's what exactly we want. And we get that by assuming by assuming that h is close to 0. Now, if we don't assume h is close to 0, that's not the slope formula for a fixed point. Now, if you see that if I keep taking this point closer and closer to A, now earlier it was chord. Now, since we are taking closer and closer, what happened is that this point A and B almost become the same point. Like it's like they become like a tangent to the curve. I mean, create a tangent to the curve. So this is what is the important thing, important key concept, that derivative at a fixed point on the curve is nothing but slope of a tangent being drawn at that point. Now let's say if I'm drawing a tangent here and I wanted to find out, let's say I know the x coordinate of this point is what is, let's say x is 2, and I know equation of this curve is y equals to x squared, and I can predict the exact slope at x equals to 2. So that's the beauty of this particular formula that we have. We'll not be using this formula for a long period of time, but let's get started with the use of the first principle formula for a fixed particular curve. So now let's say what I want to find out is, let's say I have a curve f of x, y equals to f of x is, so let's say f of x is x squared plus 4x plus, let's say x squared plus 4x is the equation of the curve. Now x squared plus 4x, when we graph, it looks something like this. So we have some let's say diagrammatic representation as well. And now first thing that we are asked is to calculate the slope formula. Now when this is slope formula, indirectly it means that it's the derivative. Now slope formula is actually it's like a fixed formula for a particular curve, where you just input the x coordinate or input the x value, and what you'll get is the slope straight away. You'll get the value of the slope straight away. Now, for example, here I've drawn this, like, I'm drawing a tangent at x equals to -1, and if I want to find the slope at this, so if you input x as -1 in that formula, straight away you will get the slope, and that is given by this one. So in the beginning we're going to use this formula, but later on we have a fixed set of formulas that we'll be using. So number one is when I have, let's say f of x is x squared plus 4x. And now I want to derive a formula, which is this is also referred as slope formula. So slope formula will be, now let us just write down this part. So f of x plus h. Now what is f of x plus h? I'm just going to first write down these separately. It is going to be, replace x with x plus h. So it'll be x plus h the whole squared plus 4 times x plus h. That's your f of x plus h. Now, when you open this bracket, guys, what you get is x squared plus 2xh plus h squared plus 4x plus 4h. Now, this is f of x plus h. And what we do is we're going to put these two values here, f of x plus h as well as f of x out here. And let's see what do we get the final slope formula. So f dash x, which is also slope formula, will be limit h tending to 0, f of x plus h, which will be x squared plus 2xh plus h squared plus 4x plus 4h minus f of x, which is x squared minus 4x over h. So what I did is basically I substituted this value, which we got here, minus f of x, which is this part. So x squared and x squared get cancelled. Minus 4 and minus 4x and plus 4x get cancelled. So what logically, actually, when you see here is that all the pure x terms should get cancelled using first principle. Now they will specify that find out the derivative or the slope formula using the first principle. Now when they specify first principle, then only we're going to use this particular formula. So important thing is now here x squared you can see and x terms getting cancelled. So what we're going to take common is, now we're going to take h common from in the numerator and denominator, we're going to cancel it. Okay, so if you're not able to take h common, that is an indicator that you have gone somewhere wrong. Just give me a second. So now if you take h common from here, what we get is h will be 2x plus h plus 4 over h. Now this h and h get cancelled, and this is the specific thing about this formula is you should be able to cancel out h. If you're not able to strike out this h, it means you've gone somewhere wrong. After this, what do? You is you plug in the h coordinate, because h is such a, now when you multiply or divide h which is close to 0, it affects the entire result. But when h you're adding or subtracting to a fixed value, it might not be that influential. So since h is close to 0, we're going to ignore this, and my final expression that I get is 2x plus 4. So this is the derivative formula for this particular curve. So f dash x that we got, or dy by dx that we got, this is the formula which is going to be applicable for only this specific curve. So according to this, what we got is f dash x is 2x plus 4. Now this is our slope formula for this particular curve. Now how do we use this? So I asked, the question is that, okay, let's say I want to find out the slope at x equals to minus 1. Slope of this tangent at x equals to minus 1. So when I plug x equals to minus 1 here, what we get is f dash x will be 2 times minus 1 plus 4. That is nothing but 2. So that's the slope formula for this particular curve. So when I draw the tangent at x equals to, let's say, x equals to 2, x equals to minus 1, it is going to be, the slope is going to be 2. Here, actually, I have drawn it for x squared minus 4, this curve, but the actual graph will be something like this. So when you look at the slope actually at x equals to minus 1, in that case, is going to look like something here. X, if I draw the minus 1 curve, is something like here. So the slope that you got for this tangent is actually, slope is nothing but 2. Now, same way, you can just input the x values and you'll keep getting the slopes. Like if I input x as 4, I get the slope at x equals to 4, and so on. So let's just take the technical interpretation about this particular expression. So now suppose if we want to find out the slope or the exact value of the derivative on calculator. So first thing what I want to just quickly show is using graph, because this can be very helpful. Now let's say I have a function. I'm just going to use the same function that I took earlier. So which is x squared minus 4, x squared plus 4x, so which is x squared plus 4x. Now, if I trace, when I trace, you can see here that there is something called as dy by dx appearing. Now, when I trace at, let's say, at x equals to -1, our answer was 2. So let's say at x equals to -1, your answer is 2. Now, this is something that tells you that, okay, at x equals to -1, y is -3, and derivative is 2. So at x equals to -1, at that instant, your y changing at the double the rate of x. And it is simple, right? If I take dy by dx is 2, if I if I bring dx here, it will be like 2 times dx. If I change the x value by 0.01, y will change by 0.02 at that point. So if I increase x from, let's say, 2 to 2.01, and see whatever the y value will be, it be that y old plus basically 0.02. So it's like, this is this basic concept. We don't need to go in depth about at this point. Now also, if you see in terms of tangent interpretation, when I say sketch a tangent at every point. Now let's say if I want to sketch tangent at x equals to -1, so you can see the slope is 2. Now, at every point, you can see the slope of this tangent is changing, and the derivative enables us to find out this particular slope. So first, let's take a couple of more examples on first principle, and then we'll interpret the actual, like, the formulas that are there. So I'm just taking one more example, which is for a rational function. Let's say f of x is, I'm taking is 1 over 3x plus 2. Now, for example, this is the function. And what I want to find out is, I want to find out the derivative expression for this. Now, when you find out the derivative expression, f dash x, it'll be a limit h tending to 0, f of x plus h, which will be 1 over 3 times x plus h plus 2. That's your f of x plus h, minus f of x, which is 1 over 3x plus 2, divided by h. Now, the only thing you have to do is simplify next step. So if I do that, limit h tending to 0, take LCM of this, 3x plus 2 minus 3x minus 3h minus 2 over 3x plus 2 and 3x plus 3h plus 2. And because you're dividing a fraction in denominator here, so it's like you're dividing like a upon b divided by c, it becomes a over bc. So this h that you see here will actually not go up in the numerator. It'll be just hanging out here in the denominator. Now, as a result, if you look at this part, I simplify. Pure x terms will get cancelled and constant terms you get is h. Now, h you can see I can strike out. So this is the thing I'm telling you, that once you have the first principle, you should be able to strike out the h expression. If you're not able to strike out, it means somewhere you've gone wrong. Now, after the step, what I'm going to do is limit h tending to 0. It is going to be negative 3 over 2x plus 3x plus 2 over 3x plus 3h plus 2. Now, since h is close to 0, this value becomes 0. And as a result of that, we get is negative 3 over 3x plus 2 the whole squared. So this is the slope formula for this particular curve here, which is really, really important. So the first thing what we have to do is, in this case, is you have the function x cubed plus 3x squared minus 7. Write down the expression for f of x plus h, which is this, minus f of x. Be careful about changing the signs. Now you can see that when I open it up using normal expansion, so what we get is x cubed plus 3x squared h plus 3xh squared plus h cubed and so on. And this expansion is this. Open up, you will see that all the pure x terms and constant term get cancelled. You can take h common, you at the end you're left with this. Now here 3xh will become 0 and 3h will become 0, x squared will become 0 because they all are close to 0. So at the end expression that you're left with is 3x squared plus 6x.